This third video on vectors deals with vector addition and subtraction and scalar multiplication. Vector addition is taking the sum of two vectors, in this example called u and v, to produce a third vector, u plus v, which is called the resultant vector. To find u plus v, we first draw the vector u, shown here, any arbitrary vector for this example. And from the terminal point of u, we draw the vector v. So here's u. From this terminal point, we're drawing v. The resultant vector, u plus v, travels from the beginning of u to the end of v in a straight path. So here we go. And that's vector addition. Vector subtraction is similar to vector addition. In vector subtraction, we find u minus v by adding the opposite of v to u. Adding the opposite of v is the same as reversing the direction of v and adding it to the end of u. So let's take a look at this. We have our original triangle right here. We looked at this on the last slide, and we have our u. The u is the same in vector subtraction, so notice the u, same direction, terminal point. In addition, we just went ahead and stuck v on the end and drew our u plus v. Here, we have to reverse the direction of v, so you'll notice that it starts at the terminal point of u still, and instead of going up off into space this way, it comes down. And just like vector addition, we'll notice that our u minus v starts at the beginning of u and continues in a straight line to the end of v. Moving on to an example. Given a vector u equal to 3, negative 2, and v equal to negative 1, 4, we should find u plus v. So first we draw a picture. Drawing vector u starting at the origin and going over 1, 2, 3, and down 2 to find that terminal point. Right here we have u. Next, drawing v from the end of u. Next, drawing v from the end of u. So going back negative 1, so 1 to the left, and then up 1, 2, 3, 4. Finding v. And the last leg of the triangle, u plus v. So now to find where this terminal point is on u plus v, we would simply add the vectors. So up here, we have u plus v is u plus v equal to our x's, 3 and negative 1, and our y's, negative 2 plus 4. So simplifying that, 3 plus a negative 1 gives us a 2. Negative 2 plus a 4 gives us a 2. And we would call u plus v by 2, 2. Finding the difference of the vectors by adding the opposite of the components of v to u. So what is the opposite of v? Well, v was negative 1, 4, and the opposite of negative 1 is 1, and the opposite of 4 is negative 4. So here we have the opposite of v equals 1, negative 4. So let's draw this picture. Same u, starting at the origin, 1, 2, 3 over, 1, 2 down. And we have this new v, 1, negative 4. So we go to the terminal point of u, and we move over 1 to the right for a plus 1, and down 4 for that negative 4. Here's v. u minus v starts at the beginning of u and ends at the terminal point of v. Multiplying by a scalar. A scalar is a constant term. Multiplying a vector by a scalar changes only the magnitude of the vector. Remembering, magnitude is the length of the line and can be found using the distance formula. If the scalar is positive, the direction of the resulting vector is the same as the direction of the original vector. If the scalar is negative, the direction of the resulting vector is opposite the direction of the original vector. Let's do an example. Given a vector v equals 3, 1, let's find 3v. So we have 3v equals 3 times the x value and 3 times the y value, resulting in the vector 3v equal to 9, 3. So let's look at the picture. Here's our original v right here. We've multiplied it by a scalar of 3, and we can see that that resulting vector is 3 times as long as our original. Let's look at 1/2 v. So again, we're going to take the scalar 1/2 and multiply it by both the values, 1/2 times 3 and 1/2 times 1. With fractions, we multiply straight across, so 1 times 3 gives us 3 over 2, 3/2, and 1/2 times 1 gives us 1/2. So our new vector 1/2 v is equal to 3/2, 1/2. Looking at the picture, we can see 1/2 v is half the length of that original v. Finally, we find the opposite of v, multiplying by a -1. We just change those signs. V was 3, 1. The opposite of v is -3, -1. Looking at the picture, seeing that our v is moving upwards to the right and our opposite v is moving downwards to the left.